So we are going to work through this question before us. It says, find the inverse function of the function this and state the domain and range of the inverse. All right, the very first thing that we need to notice here is the fact that our original function has a restricted domain. Our original function has a restricted domain. That's going to be very important because it's going to impact the domain and range of our inverse. So what are we going to do first? The first thing that I'm going to do is say, all right, the domain of my original function is 2 to 6. And the range of the original function is going to be what? Well, to find the range, I'm going to have to give it a sketch. So I know that I'm starting at 2, right? And if I put 2 into this rule here, it's going to be 2 times 2 is 4, minus 3 is 1. So it's going to be here, it's going to be 2, 1. And then I'm going to put 6 into this. 2 times 6 is 12, minus 3 is going to be 9. So when I put 6 in, I get 9 out. So this is going to be 6, 9. I'm going to put a line through this. This right here is my original function, g of x. You can see here that my range is going to be from 1 to 9. So all my possible y values. Now, the reason why I've done that is because I can now easily identify what the domain of the inverse is going to be and what the range of the inverse is going to be. So the domain of the inverse is simply the range of the function. So it's going to be 1 to 9. And the range of the inverse is simply going to be the domain of the original. So it's going to be 2 to 6. This is going to be very important when we write down our final answer. Before we do that, we actually need to find the equation of the inverse itself. So let's do that now. Remember, your first step is always to go let y be equal to g of x. So let y be equal to the function. Then you can say, well, y is equal to just 2x minus 3. Then you swap your x's and y's. Then you rearrange to make y the subject. So therefore, I'm going to get x plus 3 on 2 is equal to y. And now this is where we need to be very, very careful. When we come to write our final answer, because our original function had a restricted domain, our inverse also has to have a restricted domain. So I'm going to write it in function notation here. I'm going to say that my inverse, let's see if I can write this nicely. My inverse is going to have a domain of 1 to 9. Then I put my codomain, which is always just all real numbers. Then comma, the inverse of g is going to be equal to, and then I've got x plus 3 on 2. And just like that, I've written down my final answer. So notice that I had to write it like this because I had to specify the domain because the original function specified the domain. A very important point there. This is my final answer. Okay, let's see if we can now sketch this thing. It's actually quite easy to sketch just by looking at your domain and range. It's because I know that I'm starting at 1 and 2, right? So 1 and 2 is here. That is 1 and 2. And then I'm going 9, 6. So 9, 9, 6. That's where I'm ending. Now I can draw a line through it. And this right here is the inverse function. Hopefully you can see that this has been reflected across y is equal to x. So if I was to draw y is equal to x here, you don't have to do this, but I'm just going to do it just for fun. It's been reflected in y equals x. But the real thing that you need to take a note of for this question are these endpoints and the fact that our domain and range has switched, which is very important. And finally, if the original function has a restricted domain, that means your final answer of the inverse also has to have a restricted domain. Hopefully you have found this question manageable.